In this video, I'm going to show you everything you need to know about using AI with the MetaQuest headset. Now, in the previous tutorial, we learned how to access the MetaQuest camera and send it to ChatGPT to get a description of what we were looking at. But as you guys saw, asking ChatGPT something was done using a web request which requires an internet connection and is super slow to respond. But in this video, we are going to look at another way to use AI with a VR headset by running a local model using Unity Sentis. And at the end, we will build this very cool digit recognition system. Now, as always, you can subscribe to the channel to not miss the next video and support my work on Patreon if you want to get access to the source code and exclusive content. But because this video is all about artificial intelligence, I have the pleasure to say that we have a sponsor of choice for today's tutorial, 3D AI Studio. As you can guess by its name, 3D AI Studio is a 3D studio powered by AI that runs directly on your browser. It contains a lot of different tools to generate game-ready 3D assets like image to 3D, text to 3D. You also have an image studio to generate AI texture and even a remeshing tool to make your 3D assets super optimized. But the real strength is to use the combination of those. For example, I can go to the image studio, ask for a certain image like corgi with a VR headset, click on generate image. Ta-da! Already it looks good! Then we can ask to turn it into 3D by clicking on image to 3D. There we have some settings we can choose like face limit or to enable PBR. And if we click on generate, ta-da! As you can see, it works. I have an awesome 3D corgi wearing a VR headset. At this point, you can go to the remesh tool to optimize the mesh, or even go to the texture AI tool to modify the texture of the corgi. So if you want to learn more about this tool, go to 3daistudio.com to get started. A big thanks to them for sponsoring this video, but without further ado, let's get started. Okay, so here we are in Unity with a project already working for the Meta Camera access. Now, this is very simple. It is just here this GitHub project that I've opened, which contains a lot of things with the Meta Camera access. And if you want to follow along, I strongly encourage you to go watch the first part of the Meta Path-Through Camera tutorial series that I'm doing on the channel, where I will guide you on all the steps to open and get to this state of the project with here the Webcam Texture Manager prefab. Now, anyway, let's first talk about the elephant in the room, because as you can see here for the project overview, we have inside the project here a sample for the multi-object detection, which is actually using Unity Sentis already, and which is super good. If you just want to have a look at this project, you can go here to Path-Through Camera API sample, multi-object detection, and just open this scene right there and just have a look at what's inside. It will basically allow you to detect multiple objects all around you with the Path-Through Camera access. But I think that this project is a bit more complex if you want to simply understand how to use Unity Sentis. So that's why we are going to just ignore it right now and import our own model, which is going to be a bit more simpler than this. Now, anyway, how can we do this? Now, of course, the first step is to download Unity Sentis. And if we go to Windows, Package Manager, you can see that inside this project, Unity Sentis is already there. But otherwise, you can simply go to Unity Registry, search for Sentis, and you should be able to find it here and to download it over there. But now, because it's already in the project, the next thing that we need to do is to import a AI model. In our case, we are going to import here this handwritten digit recognition AI model that you will be able to find in the description. We can simply download the latest ONNX version by clicking here on this one, the one that doesn't contain simple test data. And there you go. Now, if we click on here, download raw file, it's going to be downloaded here, and I can simply drag it in the project. And there you go. Now, as you can see, it is already recognized by Unity Sentis, and everything seems to be good right there. Now, as I told you in the introduction, Unity Sentis allows you to run AI model directly inside Unity on devices like PC, mobile, and VR headsets without any internet connection. It is very powerful. But right now, Sentis is designed to only work with ONNX models like this digit recognition one that we just imported. And ONNX simply stands for Open Neural Network Exchange. So making our own AI model is not part of the scope of this tutorial, but if you are interested, I will leave some documentation in the description down below. But anyway, now that we have an AI model imported that can run with Unity Sentis, let's see how we can use it. For this, I'm going to right click in the hierarchy, go to create empty and rename it digit recognition. Beautiful. We can click on add component and add a script of the same name, so digit recognition. And at the top, we can simply add, as we will of course need it, using Unity.Sentis. Beautiful. So the workflow of using an AI model with Unity Sentis works in like 3 parts. We have first some initialization that we can do in the start function. Then we can run the model with public void run AI. And finally, we can clean a little bit the model by calling on disable. But now let's first see how we can initialize the model in the start function. So this is maybe the weirdest part. The first thing that we are going to do is simply add a public model asset called model asset. There we go. This will be a reference to the AI model that we just imported. Now that it's done, we can do model equals model loader dot load, and here load our model asset. There you go. Once that's done, we need to actually build a graph, which will basically send some information from the input to the output that we can get from the AI model. And this is the part that's being weird, because we need to do functional graph equals new functional graph. Once we have initialized the graph, we can initialize the input by doing functional tensor inputs equals graph dot add input model, with an S, of course, at the end of add inputs. Okay, now that we have the input, we can get the input with functional tensor outputs equals functional dot forward, and here give our model as a first parameters and the input as a second parameters. Now that we have created the graph, we can finally update our model by doing model runtime model equals graph dot compile outputs. Okay, and at this point we have a runtime model that we can use, and the last thing that we can do is create a worker that will be able to, well, put everything together and send a request that we can ask in the run AI function. So I'm going to go at the top and create a private reference to the worker, which I can call worker, and simply do worker equals new worker, and here give our runtime model for the first parameters. And here for the second parameters, we can set the backend type of the worker. Does it need to run on the CPU, GPU compute, GPU pixels? Now by default, I will set it simply to GPU compute. If you are interested in learning more about the difference between CPU and GPU for the AI model, there is here some recommendation that Meta has written here on their documentation. I will leave the link in the description down below as well. Now, anyway, we have finally done the initialization of the AI. Now it is time to actually run the AI. Now, in our case, for the digit recognition, we are going to take as an input a texture 2D. So we can actually use a texture 2D that we can call picture here for the run AI function. And then we can actually turn this picture 2D into float tensor by doing using tensor float input tensor equals texture converter dot to tensor. And here use our pictures. Then as you can see, there is some settings for the width, the height and the channels. We can, for example, set a width of 28, a height of 28 and a channel of 1. So basically what this is doing is actually set a certain width and height for the texture. So it will basically scale the input texture to have 28 pixels on the width and 28 pixels on the height. And here at the end, we can actually also customize the channel that it will use. And because we are setting it to 1, it will basically only use the grayscale channel of the input texture, so no color will be used. And this is actually what we want for our digit recognition. Now anyway, now that we have an input tensor, everything is basically done for running the worker. So we can simply do worker.schedule and then use our input tensor. Beautiful. So now the worker that was initialized on the start can run our input texture. And at this time, we can simply wait and get some result. And if we simply want to get the result, we can simply do now tensor float output tensor equals worker.peak output as tensor float. So as you can see, we give as an input to the worker an input tensor. We get as an output output tensor. But now we can convert it back to a certain array of result by doing float result equals output tensor dot download to array. Beautiful. And there we go. Now that's done. Now a thing that I'm going to do is actually, instead of using here a local variable for the float array result, I'm going to just use a global variable at the top. So I'm going to do public float result over there, so that the result will also be able to be written in the Unity inspector, which will be very handy to understand what's going on. And now the last step is on the disable, just to dispose the worker. And there you go. We have now the 3 steps of running a Unity Sentis model. First, initializing graph for the worker, then running the worker with a tensor, and finally clean everything on disable. Okay, so everything should work. Now the only thing that we need is of course to just test it. So what I'm going to do is add here a public texture 2D, which I will call test picture. There we go. And at the start, what we can do is run the AI with the test picture. Beautiful. Now we can save, go back to Unity. There we go. For the model asset, we can drag here the model that we imported at the start over there. For the texture 2D, we need to add here a random handwritten digit. So if you go on Google Image and simply search for handwritten digit, you can get this one. So right now the AI works a bit better if you have a black background. So I encourage you to select one of those, for example, or here this 3 number. Now we can simply save the image and drag it inside Unity. Beautiful. Now we can drag this texture over there on the test picture. And now let's test if this is working by simply clicking on play. Okay, and look at this, something very interesting just happened. Now, as you can see, we have some result. For each different number from 0 to 9, we have a certain value next to them. And next to the value of 6, we have the higher score, which is 14.36. So the AI is working correctly and was able to give us the best result. But of course now the values are a bit random, but there is a way to turn this value into probabilities using a softmax, and this is what I'm going to show you. If we open back the script and if we modify slightly the graph at the top, we can simply apply a softmax, which will turn this random value into probabilities by doing functional tensor softmax and do functional dot softmax with output 0. And there we go. Now if we give the softmax into the graph.compile over there, if we save, go back to Unity, and now if we click on play, there you go. As you can see, it changed. But of course, right now the results are a bit weird because it is like an array. So if you simply want to return the best result, so the one that has the highest probabilities, we can slightly modify here our digit recognition. So to do this, we are going to create a public int function called getMaxIndex, which will take as a parameter a float array. And the script will basically return the index of the max value. So we can do int max index equals 0 and then loop through our array by doing for int I that goes from 0 to array.length. And this will be very simple. If the array I element is greater than the array max index, then we can simply say that our max index is equal to I. And then at the end, simply return the max index. But we can get a bit better than this because using this getMaxIndex will return the maximum index. But what happens if the AI is not really sure about the result? It will simply here display something that is not sure. So I think a good thing to do is actually to use a certain probability threshold by doing public float threshold and set it to 0.9, for example. And basically, in the case of getMaxIndex, if array max index is greater than the threshold, we will return the max index, but otherwise we will simply return like a default index, for example, -1. And there you go. This will make sure that only a value above threshold will return a good max index. So now on the run AI, we can basically return, instead of void, we can return an int, and with our result, we can do return get max index with result. Beautiful. And now just to test, instead of running the AI, we can simply do debug.log run AI test picture. And let's have a look at if this is working and actually just writing in the console the result. So let's save. There you go, and now if I click on play, as you can see, it is working. It is now writing in the console the maximum value on the result array, so everything is working well. We can now use digit recognition with Unity Sentis, which is awesome. But of course, what's missing is to actually use it with the meta path-through camera access, and this is what I'm going to show you right now. Okay, so before recording this tutorial, as you can see, I have prepared here a game object called path-through crop camera, and if we enable it, this game object contains like a quad as a child, and as a parent, it has a path-through crop camera component. Now, if I open it, we have two main functions, the take picture function that we have here and the play squad function that we have here. Now these two functions are actually based on the first tutorial for the meta path-through camera access that I've posted, where we actually use these two functions to take a picture and place it in front of the player. But the big difference with these is that they are the same, except that they are not taking the full picture of the path-through, but a crop version of the path-through. And as you can see, everything is told here by this crop percent. So for example, if the crop percent is 0.5 for a full image path-through, it will basically divide the width and height in two and just crop the image to only take the picture of this part. And now down below, we have also the play squad function, which will basically place a quad inside this smaller cropped area. And of course, this is going to be very helpful because this will give us kind of a zone that we can send to the AI for the digit recognition instead of like sending the old path-through camera access. But this is going to make so much more sense in a minute, so stick with me for now. Now, in the update function, we are going to check if the webcam manager.webcam texture is there, otherwise we are going to return. And then we are first going to place the quad to show the area that we are taking picture. And if we place the quad, we are going to take a picture of the crop area. Now, as you can see, this take picture function will actually update this texture to the picture variable. So we can actually create a public reference for digit recognition that I'm going to call digit recognition. And what we can do is call digit recognition.run AI with the picture variable. Awesome. But of course, this return an int. So I'm going to do int result equals digit recognition run AI picture. And this is where things get very interesting because this is where we can write some information on the prediction that was done by the AI. For this, I'm going to do public tmpro.textmeshPro and call it tmp. So this will be a text that will write the prediction. And if the result is greater than 0, what we can do is do tmp.text equals prediction plus the result. Now, if the result is less than 0, it means that the probabilities was a bit too low. So we can simply do tmp.text equals nothing. And there you go. Now I think everything is good. We can save and now go back to Unity. Awesome. So now we need to set up the digit recognition. So we can simply drag it over there. And we can also set up the text mesh pro. So for this, I'm going to select my quad over there and I'm going to right click, go to 3D object, and then text mesh pro. There you go. We can scale it down and maybe set for the text to be center. Beautiful. We can also make it wider and put it down below, like this seems good. And now we can simply drag this text over there on the tmp variable. And there we go. Now, as you can see, the crop percent is set to 0.25, which means that only 25% of the whole path-through camera access will be used. For the quad distance, it is saying that the quad will be positioned as a distance of 1 meter, but we can actually maybe decrease this value to 0.4, for example, so 40 centimeters far from us. And there we go. I think now everything should be good. We have the digit recognition and we have here this path-through crop camera, which is actually calling the digit recognition every frame of the game by sending a crop path-through camera picture to it. Oh, and just before I forgot, guys, before building, you can actually do some improvement with what we have here on the webcam texture manager prefab. As you can see, the requested resolution should be initially to 00, which is the max resolution, but we don't need the max resolution, so you can basically set it to 320 to 240. This will be a bit more optimized. And another cool thing that you can do is that on the path-through crop camera, if we open the script, what I've just done just to simply understand understand a bit better what's going on is to create another quad renderer, which will on the take picture function simply display the picture on the material of the quad. This way I will be able to know what exactly we are sending as an input to the AI. And I have here this display image which should do the job. So anyway, now everything should be good. Let's build and run by going to File, Build Profile, make sure that Android is selected over there, and then click on Build and Run. And there you go guys, what do you think about the result? Now we can easily recognize digit in no time using a local AI model running directly on our MetaQuest. So of course this is really the fundamentals of using Unity Sentis with the MetaQuest camera, but if you want to have a look at a more advanced model, I strongly recommend you to have a look at the multi-object detection sample that is contained inside the GitHub Path-Through Camera API sample project. Now thank you for watching this video till the end. Don't forget to subscribe to not miss the next video. We are getting closer to 50,000 subscribers, and make sure to join our Patreon where you can get access to the source code of this project and exclusive content. Thank you for watching and see you very soon. Bye bye.